I'm Praveena from Group 320. I'm going to explain about the methods of investigation of the structure of biopolymers. In this one, my topics is luminescence and optical activity. In luminescence, when pH of 8.0 causes a change to coil structure, the two distinct bands appear due to the Davidoff splitting, and it is a significant reduction in absorption like hypochronism. In this one, it cases strength of the long way wavelength absorption band of the alpha helix decreases by 30%. For example, if we talk about it can measure this light absorption, change it to estimate how much the protein is in the alpha helix versus the coil form. This technique works well for nucleic acids like DNA because their absorption is easier to measure 60 nm to 60 nm like compared to proteins which are heads to measure at the around 200 nanometers. Like if we talk about when molecule recited, they are either emit or less loss energy at heat. For this equation, the equation shows predict how quickly the numbers of excited molecules decreases as they lose energy through the two processes. The next equation, this one, the equation shows how the numbers of the excited molecules decreases over time as they lose energy either by um, heat, fluorescent or heat. This equation shows the quantum yield gamma is a relation that shows how much of the energy is emitted as light fluorescence versus the host of the heat. The higher quantum yield, the more efficient in the fluorescence. Like example, the ability of the trypsin and tyrosine to emit fluorescence changes based on the protein structures and environmental meaning their fluorescent is conformationally sensitive. It can tell us about changes in the protein shape and surroundings conditions. Example, the things changes in brightness of fluorescence shows that the protein has unfolded. The more exposed it becomes, the brighter the fluorescence, giving you a simple way to know if the protein structure has changed. The study of luminescence, especially in the aromatic amino acid, is valuable for conducting the protein structures and interactions. Next topic, if we talk about the optical activity, chiral substance like biopolymers can rotate the plane of polarized light because of their structure. The structure of the protein occurs due to the difference in how quickly the right-handed, like left-handed circularly polarized light travel through the substances. The amount of rotation depends on the proteins and the substance and the thickness and the layer of the light it passes through. Like example, this example shows rotation of polarized light in a chiral substance depends on how much the refractive index differ for the left and right handed and the thickness of the substance. The next equation shows how to calculate the specific relation of the chiral substance. It tells how much the polarized light is rotated by the substance in relation to its concentration. And this equation shows it calculates optical of a purity of the chiral compound and based on its observed optical activity. Consider to its expected activity were pure. Like this equation shows it helps to quantity of optical rotation of a polyamino acids in a coiled state, like particularly focusing on how the structure features and light property interacts. And its next equation shows it describes how the total optical rotation of the chiral substance is influenced by the different molecules and its configurations. And this equation shows it describes how the total optical rotation of a chiral substance is influenced by the different molecular configuration. Like if we talk about due to amino acids residues, like the fraction of helical portions. The next equation, it provides a way to calculate the optical rotation due to its amino acid residues based on the helical content of proteins. And this next equation, it shows various factors that combines to optical activity, allowing for the prediction and how the structural changes influence the optical proteins. conclusion, if we talk about the quantum mechanical theory of optical activity, it helps us to understand how the light interact the chiral polymers, particularly focusing on the structure and interactions of monomers and the ability of the rotate light, whether it is strong or weak, and determines and like in the polarized light in the right hand wave, electric field strength vector in a ray directed towards the observer rotates in a clockwise direction. In the left hand wave, the vector rotates in a anti-clockwise direction. Like a linear polarized wave can be resolved into right hand and left hand circularly polarized components. The electric vector it's oscillating along a single direction in the sum of the two vectors which rotate circularly in a clockwise and an anti-clockwise direction. If one of these components propagates faster than the other, the resultant vector at an angle is the larger. The greater is the velocity. The difference, that is, the higher is the difference of the refractive indices when the ray is passed through a layer of substances or thickness, like it rotated through an angle. About the more about optical activity, thus cannot neglect the distance between the electrons of the molecules, which can be the lightweight or strong weight. It is also necessary to take account of the interactions between these electrons in the absence of such interactions. No optical activity is present in this one. And the finally molecular crystal must be chiral. That is, they must have neither plane or center of symmetry. Like the rigorous quantum mechanical theory of optical activity, Rosenfeld rotation of the plane polarized in expressed for an isotropic medium that contains chiral molecules. Like the present day advancement of the spectropolymerity is directly tied up with the investigations and structures of natural compounds with the bioorganic chemistry and molecular biology. Like spectropolymmetry has gone through the three stages of development at one time, like molecules, crystals were characterized only by the values at a single light wavelength. This gives very scarce information. The later the scientist turns into a measurement of like outside the region of absorption. The final the scientist become interested in the measurement of cotton effect and in the CD region of absorption. Thank you. This is the conclusion of my topic.